All right, welcome back, geometry students. Today we're going to look at section 4.8, where we use isosceles and equilateral triangles. If you would like to copy down that big idea, feel free to pause the video here. Okay, so let's recall a little bit about an isosceles triangle. So we know, for one, that an isosceles triangle has at least two congruent sides. Okay, so that's what we've talked about with an isosceles triangle so far. But we're going to take a look at a diagram because there's a few new terms that we need to see, especially in the theorems that we're going to get in this section. So the first terms I'm going to talk about are the sides of those triangles, which we call the legs. So our congruent sides are called the legs. Okay, we see those marked in green in the diagram. And then we also have one that needs to be written in here. The third side, which is not congruent to the other two, we're going to refer to as the base. All right, now let's take a look a little bit at the angles. So up at the top, we have vertex point A. The vertex point is wherever the two congruent sides meet, which again, we're going to call our legs. So those legs meet at point A, that is our vertex point, and they create the vertex angle, which is marked there in blue. Now the other two angles we're going to refer to as our base angles because those two angles are located on the base of our isosceles triangle. So make sure to copy that diagram into your notes. But let's take a look at our theorems. Okay, so again, pause the video here to copy these down, and then you can listen to the description. So theorem 4.7 is the base angles theorem, which says if two sides of a triangle are congruent, then the angles opposite them are congruent. So over in our triangle ABC, we have two congruent sides, so AB and AC. So those two congruent sides are going to indicate to us that the opposite angles will be congruent. So the angle that's opposite of side AB would be angle C, and the angle opposite side AC is angle B. So since I have those two congruent sides, I get the two congruent angles. And just as a little side note, those are actually our base angles that are going to be congruent here. All right, so theorem 4.8 is actually just the converse of theorem 4.7. In this, if we have two angles of a triangle that are congruent, then the sides opposite them are congruent. So we're really just going in reverse. You'll notice in the diagram to the right that the angles B and C are marked congruent. So if we look at the opposite sides, the side opposite of angle B would be side AC, and the side opposite of angle C would be side AB. So we know that those two sides would be congruent. Oops, sorry, just fix that up a little bit there. All right, so these two theorems are pretty much telling us the same thing. If we know we have either two sides or two angles congruent in a triangle, we can get the opposite pair also. Now, because that's true, we also have a few corollaries. So don't worry too much about the name. What we're going to do is focus in on what the actual theorem says. So the first part here, if a triangle is equilateral, then it is equiangular. Okay, so in our triangle ABC, because all three sides are marked congruent, we can say all three angles would also be congruent. Now the converse to that is true. If a triangle is equiangular, then it is equilateral. So all of one automatically makes the other true. If all the angles are congruent, so are all of the sides. All right, so a few short examples here. Well, it looks like we have triangle STU, and we can see in the diagram that side ST is marked congruent to side UT. So now that we know our theorems, we have to figure out which two angles would be congruent. In this example, you just want to look for the opposite angles. So if I look at side ST, the opposite angle would be angle U. And if I look at side TU, the opposite angle would be angle S. So I know that angle S is congruent to angle U. Okay, and this is by the base angles theorem. All right, so hopefully simple enough. That makes sense. So let's take a look at the example 2. In this one, we're finding the measures of angle A and angle C. So in my diagram, I can see I have an isosceles triangle because AB is marked congruent to BC. So put that over here. AB is congruent to BC. And because of that and the base angles theorem, so by the base angles theorem, which I'm just going to shorten to BAT for now, by the base angles theorem, I know that angle A is going to be congruent to angle C because those are the opposite angles. So I'm going to mark that in my diagram. Okay, so let me see what that means then. I know I can name one of my unknown angles. I'm going to call it x degrees. So we'll call angle A x degrees. Since angle A is congruent to angle C, I can label angle C the same way, x degrees. All right, well, let's set up an equation. We know from the triangle sum theorem that the total measure of the angles in a triangle is going to be 180 degrees. Okay, so I know that 180 degrees is going to equal the sum of all three angles. I have 120 for angle B, x degrees for angle A, and x degrees for angle C. All right, I'm going to simplify that a little. So I'm going to leave off the degree symbols for now and just say 180 equals 120 plus 2x. All right, so now we can solve. Subtract 120 from both sides. I have 60 equals 2x, and then I can divide by 2. So I end up with x equals 30, and that's telling me both of my degree measures. So the measure of angle A equals 30 degrees, and the measure of angle C equals 30 degrees. All right. Next example, a little bit more complicated, so let's take a look at what we know. We're looking for the values of x and y, and I can see multiple triangles in the diagram. So for one, let me just highlight these for you quickly. We have triangle KNL, which is right here, and triangle KNL has 3 congruent angles marked. Okay, so it's equiangular. We also have triangle NLM, which is down here. This one has 2 of its angles marked congruent. Okay, so I can see that that one is most likely going to be an isosceles once I use my base angles converse. So let me mark what I know then in the diagram. Let's go back to our regular pen. I know in triangle KNL that because it is equiangular, it will also be equilateral. So I can mark all 3 sides congruent. All right, now I'm going to take a look at triangle NLM again. In that one, I see the base angles are congruent, so I'm going to use the converse to the base angles theorem. If I know that N is congruent to M, then side NL would be congruent to side LM. So I'm going to mark that one congruent also. And I can use one tick mark because since I already used that tick mark on side NL, LM will be the same. Okay, so let's go back. X. In my triangle KNL, since it's equilateral, I know that X is simply going to equal 7 because it's the same length as side KL. I also know that side NL will equal 7, so I'm going to put that in my diagram because now I can relate that to side LM. Okay, so y plus 4 is LM, but we know it's congruent to side NL, which equals 7. So now we can solve for y, and we get a value of 3. So x equals 7 and y equals 3 are our 2 variables here. All right. So this last example looks like we got a little bit of an overlap here. We're going to wait and take a look at this example to start off class. Okay, but feel free to take a look at this one and see if you can figure it out. Let me adjust here a little bit. So the first part of the question is saying explain why triangle PQT is isosceles. Oh, sorry, that's part B. Part A, what congruence postulate is going to prove triangle QPS and PQR are congruent? And the last question here, we're going to show that triangle PTS is congruent to triangle QTR. So we had some information given to us at the top. Again, feel free to give this one a try on your own. And if it helps, sometimes just seeing the diagram without the picture can improve your understanding. All right, so we'll start with this one in class. Make sure you bring the notes with you and any questions that you have. I'll see everybody there.